Hello Pratham, am I audible to you? Hello Pratham. Hello Pratham, is it audible or not? Hello Pratham, I'm not able to hear you. Hello.
Can you hear me now? Hello.
Yeah, hello Pratham, is it audible?
Yes, you are audible.
Okay, so we can continue, right, from the topic you've left.
Yes.
So yeah, I have shared my screen.
Yes, sir.
Okay. So yesterday we completed some basics of electric fields. Okay. So today we are going to go with the second part of that. Okay.
Okay.
All right. So yeah, before that, I think okay, we'll do this question after this. Okay, let's discuss some properties of electric lines of force.
Okay.
Properties of electric lines of force. I already told you the electric line of force is nothing but these lines, right?
Yes.
So force. In some book you will see them as electric field, or somewhere you will find them as electric lines of force. Okay, so what are the properties? So the first property which comes up is electric line of force, or I can say electric field. You know that electric field starts from where? Starts from it start it starts from where? A positive charge, right?
Yes.
And converges at
Negative charge.
yeah, and ends at negative charge. Okay, next one. What can be the next property? Okay, so just assume I have a electric field like this. If I ask you what is the direction at this point of this electric field, how you will get to know?
Uh, Sorry, what?
I'm asking like just assume I give you some figure, okay, and for a charge, the electric line looks like this, okay. So if I
Okay.
ask you what is the direction at this point and what is the direction at this point of for electric field, how you will decide that? You know that this is positive
Towards
charge.
the
Let's say
negative.
you know electric field is going this way, right? But if I
Yes.
ask you what is the direction particularly at this point and what is the direction particularly at this point, so how you will be able to discuss like what is the direction?
I don't know, maybe towards the negative charge only.
Okay, so basically general idea I'm giving, if any curve is there, look, if some line is like this, right? So in that case you will say okay, this is the direction itself. You don't have to make anything. But if any curve is there and if someone asks you what is the direction at this point,
Tangent.
so you have to make a tangent at this point. Okay,
Okay.
particular tangent at this point, and let's say you are going from here to here. So this is your direction. Here what will be your direction? Like this, the tangent. So
Got
here
it.
this is your direction, here this is your direction. So what I can say that tangent drawn at any point, tangent drawn at any point in electric field gives you the direction, provides you the direction of electric lines of force. Okay? Is that clear?
Yes, sir.
Oh, fine. So what's the next? What can be the third property? Any idea?
No.
All right. So look, uh, the third is two electric field lines never intersect each other.
Yes.
Never intersect each other. each other. That's fine. What can be the next property? They never make a closed loop. They never make a closed loop. Basically starts from a positive one and set a negative one. A very general idea is that if something has been started, it had to end somewhere. Okay, so they have a positive charge, they are going to end at that itself. It is not the case that it will go and revert in the universe and come back to its position. It's a loop. Okay, so they are not going to make any loop starting
Okay.
from a position terminating at a. Okay, so it starts from positive and terminate at negative. Understood?
Yes.
Okay. Electric. Okay. One more thing. At the surface of conductor, at the surface of conductor, they start normally. Okay. They originate normally, net or terminate normally. What this means? Let's discuss this also. Look, if this is a small point, right? So here you can
Yeah.
say that it is going like this. A very simple point is there, so you don't have to discuss about the directions too much. But if I say this is a block, okay, this is a conducting block, and you have, let's say, charges at this surface. And if I ask you, in what direction your electric field will look like? Will it look like this, or will it look like this? Uh, Perpendicular.
Perpendicular.
Perpendicular, right? Why this
Yes.
goes like this? Just assume if you take only one point, too many charges are. Let's discuss only about the two charges. Okay, so I have two
Okay.
charge. This alone charge will be having electric field in all the directions,
Yeah.
right? Let's say I'm not saying that it will provide electric field inside direction, because electric field inside a conductor is zero. We'll prove this in further section. Okay, just assume there is no electric field inside.
Okay.
So yeah, now uh, uh, this person providing electric field like this. Okay, because too many charges are there will another charge over here also, he will be having electric field like this.
Yeah.
This If you see carefully, at least there will be one person who is ready. Okay, now this electric field can be resolved into like this, and can be resolved like this, is it?
Yes.
I have to make it. Let's say this is the horizontal component, and this is your vertical component. Okay, so if you
Okay.
see, this can also be resolved in this, and this can be resolved in this. So if you see, at least there is someone in the opposite side who can terminate this horizontal component.
Yes.
But there is no one who is ready to terminate this vertical component,
Yes.
right? So I can say that in all conditions you will be having, like, you are only left with the vertical, basically this perpendicular one component. That's why we say that net electric field goes only the perpendicular one. Understood?
Yes.
Okay, you will say that this last point, if I resolve this one, so he don't have any charge who can terminate from this side, right? This is also you can say.
Hmm.
But if you
Yes.
see carefully, when you have resolved it, it ended up like this, right? So if you see, this is looking like a vertical component at this position,
Yes.
right? So at the end, I can say that electric fields are only perpendicular to that surfaces.
Okay.
Is it clear?
Yes.
Any doubt? Any kind of special doubt we have?
No.
Okay, fine. Let's not remove this. It will like this, 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 this. surface, perpendicular to the surface. That's fine. Okay. So what's the next property? Basically, we have covered, I think, how many properties? Five properties are we have covered. Okay, that's fine. These are more than enough. Okay. Another property is um, if intensity of electric field increases with the increases with the density. What this means basically, just assume you have a charge of 5 coulomb. Okay, so you know this is, and I have another charge is 100 coulomb. If I ask you at some radius r, who is going to provide more force or for more electric field lines, more
100.
electric field intensity, so you can say this 100 coulomb, right?
Yes.
What's the reason behind this look? Due to the density. You can see here its density will look like this.
Yes.
Although these all things, when we say electric field and when we are making electric field, all these are uh, imaginary thing. Okay,
Yes.
but in this case you'll find too many closed lines.
Yes.
Okay, very close. With other electric field, instead of density I'm just saying this field lines. Okay, so if you have electric field like this, okay, A point, B point, C point, D point. What do you think? Electric field at A, B, C, D. All are equal. Okay, I'm just giving some options. A equals to B, equals to C, equals to D. Okay, length is 1 meter, 1 meter, 1 meter. Okay, yeah. A is greater than B. A equals to B, greater than C equals to D, or the opposite. Which option do you think is correct?
And the charge is at the left hand side.
Charges, yeah, maybe charge might be somewhere here. Just assume somehow you are seeing a parallel electric field lines. What do you think? What will be the option in this case? Look, in further, it is not necessary that when we are solving the problem, you will be giving the charge. Maybe the question will only give you the electric field lines. Okay.
Okay.
Yeah. So, what options you can expect? If you want, I can just make these lines little bit better. So, it's like this. Another electric field lines. Another electric field lines. All are parallel. Okay. And distance between them is same. Tell me which option seems correct.
I think the first one should be correct.
Yeah, first one should be correct. The reason behind this, I don't know what is electric field. Okay, so let's say I'm just calling this to be the electric field. If I'm seeing these two lines and these two lines, they're same because they're parallel. So basically, the distance between them is same. It means
Yes.
there's no change in between them. So this will also be the same. Same case goes with this also. So yeah, overall all of them are equal. Okay, but if some case is like this, A and B, like going like this. Okay, maybe negative charge is there, that's why converging. Okay, this is you can think, and maybe a bigger positive charge somewhere here was there, so it was going like this. Okay,
Okay.
forget that point. What do you think electric field is? Okay, here or here, where you will be having a greater electric field?
At the B part,
Yeah, exactly. At the B part,
because
it
there
will be
is high
great. Okay,
density.
I'm asking magnitude, so it will be greater at this point. So even you got have a little bit idea also. If you see carefully, when it was about to converse, it was going towards a, it was close to a charge, right? It was near to a charge.
Yes,
Here you can see when you are near to the charge, you will be having a better electric field.
yes, yes.
Okay, it's the same condition. Okay, so I can just remove it. Okay, so this is one thing, and yeah, so these are some properties. All right, so let's discuss some different type of different patterns, basically some different patterns. Different pattern of electric field. Okay. So what kind of patterns we can notice? So first one is a constant one. In this case, if you see carefully, the magnitude is constant. Is it?
Yes.
Okay. What can be the other one? This kind of. What do you think? What about the magnitude? How will be the magnitude? Will it be different or constant?
It should be the same.
Yeah, magnitude is same. Okay, magnitude is constant. Okay, let's talk about the direction in both cases. Okay, I will not try to constant and I'll just put tick or not. Okay, so magnitude is constant. What about the
Yes.
direction?
If we take the tangent, then the direction is also the same at
Basically,
each
direction
point.
is changing, right? If you see this point, this at this point, this.
For one curve, it is changing, but if we make it similar
No,
points
no,
on each,
no, no. Even for a one curve, the direction is not same. Although, look,
yeah,
electric field basically you don't have to just see one curve. Okay, you have to see all of them as a single. Basically, all of them might be due to a single charge itself, right? It's not the case that this is coming due to some other charge. No, that's not the case. Okay. So if you see carefully, if I just make a tangent at this point, what is the direction this? If I make tangent at this point, what is the direction? Like this.
yes, yeah,
Direction is varying. So I can say my direction is varying. What about this case? The first one,
direction is same.
direction is same. Direction is also same. This was the second condition. Okay, let's make the third. What about this one?
Magnitude and direction both are different.
Magnitude and direction?
Both are different.
Yeah, both are different. I can say magnitude and direction both are different. Okay, that's fine. Okay, these three we did in the first one. I made it. Okay. So look, if I have to give you in which magnitude is different, so I can just make like one more line. So you can see these things goes closer. So in this case, I can say the magnitude is inconsistent, right? This has greater
Yes.
magnitude as compared to this one. Okay? So I'm just removing it. I'm not making it. Okay. So these were some points. Yeah. This is for a single positive, single charge. Okay, single positive charge, I can say. Why I'm saying, you can, if you see carefully, it is going all around, right? So means to say it's a point charge, and it is going outwards. So I can say it is a positive charge.
Yes.
What can be the next option? Let's have a condition of one negative, another negative, one positive. So in this case, what kind of electric field you can observe? Like this. These kinds of electric field you are supposed to observe.
Yes.
Okay. Okay. Clear?
Clear.
Okay. So one positive and one negative charge. Is that fine? Let's take two equal positive, two positive charges. So we are not saying whether they are equal or not. So this is also positive. This is also positive. Now, if you see carefully, both are positive. They
Yes.
both wanted to go outside. It means they will be doing some conflict like this.
Yes.
Okay. So let's say he started from here, he reaches here. He started from here, reaches. He see one another electric field is coming. So instead of intersecting something, because they can't do, so
Yes. Diverge.
they will just end up and change their direction in a curvical position.
Yes. Yes.
So it will like this. Hmm.
You don't need to draw the whole thing I have drawn in my notebook.
What?
You don't need to draw the whole thing I have drawn in my notebook.
Okay, you have drawn the notebook, right?
Yes. Yes.
That's fine. Both positive. Another condition. Okay, let's not put too many conditions. Okay, because the next one will be like one is greater, one is smaller. So yeah, if one is greater, what will happen? It will be having too
It will
many
go
electric field
in.
lines closer to it, and if it
Yes.
is someone is smaller, it will be having a lesser electric field line density.
Okay.
This is what we are going to observe.
Okay.
Nothing more than that. Mm, just a second, let me check. Okay, so I'm giving you one problem. Okay, so the problem is charges q and minus 2q are fixed at a distance of d.
Okay.
Okay, I think here I can put the problem. Problem. Uh, yes. Q and minus q, not negative, it's minus 2q, are placed apart at d distance. Okay,
Okay.
you have to tell, and okay, where to be the third charge should be placed, or just let me know the electric field is zero. Okay, so the position where third charge should be placed, third charge should be placed such that it experiences no force. Says no force. Understood?
Okay.
Uh, if you want figure, you can assume one positive is like this, minus 2q is like this over this side. Okay, and the distance between them is d.
Okay, give me one
Okay,
second. I will
so
just
yeah,
solve
this
it.
is the question you have to take. Yeah, so this is the condition given to you with distance d. You have to get me the position of a particle. Okay, even if you want to know, you can assume this position vector to be 0. Okay,
Yes.
and assume this kind of thing, x in this way, y in this way. This is basically, you can say, origin. So where I should place my third charge? Yeah, one more thing. This one is negative. If you could remember, this one is negative.
I'm getting the quadratic
What?
equation.
Okay. What happened?
I'm getting a quadratic equation.
You are getting.
Quadratic equation.
Okay, you are getting a quadratic equation.
Yes.
Okay, what's that?
It is 3x square plus d square minus 2dx.
I don't think it will be the answer. Okay, just tell me what procedure you did.
I first I took the distance of Q3 from Q1 and then Q3 from Q2.
Okay,
And
look. First of all, what you understand by the question and what I want to I have to extract it out.
so first we need to equalize the force from both the sides so that it doesn't get force from any side. Like the
Okay.
Q3 charge doesn't get experience
So
any
if
force.
look, if you see carefully, we have to place one more charge, right? The third charge,
Yes,
and I don't know
yes,
what kind of charge is that. Okay.
yeah.
So if you see which are the possible condition I have where I can put the charge. So if you see carefully, I have this reason, I have this reason, and I have this reason. Is it
Yes.
okay? So how I will decide that I have to go with this reason, and this reason?
Mhm.
Which factor will give me a better solution? Like what thing I should what I should think that where I should put my third charge. How I will decide. Look, the first option is just make a very random equation, okay, where you will be putting d plus x or something like that, and put on the basis of proper vector form. In that case, even now does it, even you don't know where you are going to place it. Final answer will result when assuming some x equation, you will get some answer. On the basis of that, you can say, okay, here I'm going to put, here I'm going to put, or here I'm. But even without that, how you will be thinking like where you should put the third charge?
So if you put in the leftmost, then it will push the Q1 charge away.
Yeah, exactly.
So
So you have to put in the this part, right?
yeah,
Okay, so like idea behind that is I have to put the third charge. Okay, third charge means electric field should be zero due to, because there are two charges. So due to one, either it will be like this, either it will be like so. I have to get the position where my electric field due to both charges look like this. Is it? So if you see
yes,
carefully, if I am placing anywhere in between, this is positive, so it will always try to go like this, and this person will always try to take like this. So in this condition, in between, anyhow, whether I start from here and here, there's no condition where I can get the electric field is zero. Is it?
yes,
Okay. Okay, so let's start. Then I thought of this. If I see that side, due to this negative, my electric field look like this. Due to this
yes,
positive, my electric field like this. But again, this is a smaller charge. Okay, so a very simple idea is there. Due to this one, the its electric field at this region will always be very smaller as compared to this one, because this position is closer to this charge, right?
yes,
So its electric field influence will always lesser than this, even though its the magnitude is itself very low. But if I
mm,
just figure out another way, if I say, okay, I can think of this position. Okay,
yeah,
this point is closer to this but farther to this. Okay, but still there is possibility because the magnitude is not equal. This charge is also lesser, so there might be one possibility that in some situation I get one position that electric field due to this and this comes out equal in magnitude at this position. Okay, so this is how I
okay,
can think of it. So what I'll be doing is nothing. I'll assume this as a random x. Okay, so what will the electric field due to this point, because at this point I need force to be zero on the other part. So if force I need zero, mean to say what is four electric field and q, I don't know what is the this third charge. So I will do, I will find out the position where electric field comes out to be zero. Okay, so electric field due to q, what it will be, it will be nothing but k q. What is the distance? If you see, this is only x square. Electric field due to the bigger minus 2q, what it is, k 2q divided by uh, d plus x square. Is it clear?
yes,
Right, the distance you can see it goes very big. Now what I had to do, I want, if I add both of them, the answer should come out to be 0. Okay, so when you do this e net, what we are going to do, kq by x square minus 2kq divided by d plus x square. Okay, one more thing I told you, like you have to add it, but I am doing negative. Why I am negative? Because when you are going with directions, like when you are putting the scalar quantities, you have to think of the direction by yourself. Okay, but when you are putting the vectors, you don't have to think of the direction by yourself. The vectors will take care of it by itself. Okay, so if you
okay,
see, I was putting the magnitude. Okay, I was putting the magnitude, so that's why I know the electric field due to this one will be this direction, it due to this one will be this direction, opposite side are there, so I have to subtract it out. Okay, just assume I don't know electric field direction also. So in that case, what I'll do, if I go with the vector way, I know electric field due to this one is this itself, but due to this one will be KQ. And if you see charge is negative, so negative. When you add it up, it will become this itself. Understood?
okay.
And the final should come out to be zero. Cancel, cancel. So what you got? 1 by x square equals to 2 d plus x.
Yeah, this is coming to be unreal. I got the same equation.
Okay, so this is what you got, right?
Yes,
That's fine. Okay, it is fine actually. because when you solve it out, it will become like just put this square to that side. You will be getting d plus x divided by 2 under root 2. It will be under root 2. So if it goes that side, so your x will become something like this x will be like this, so it will go like this. Yeah, so your answer will come out as d divided by under root 2 minus 1. You can just solve this part, just the above equation. When you solve this equation, you will get this equation directly. Okay,
Okay.
is that clear?
Oh, okay. 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 Okay.
All right. Any doubt?
No,
Okay, so I think your today's session was just for the 40 minutes, is it?
I think yes,
Yeah.
yes.
Okay, so yeah, this is all for the session. I think your session is very.
So in the next class, what will be complete?
In the next class,
What will be complete?
I didn't understand. Like,
In the next class, what will we do? The
okay, what
topic.
we okay, which topic we are going to do?
Yes.
I think, look, I will be starting with the main topic, basically the application part of this, the field of ring charges and all.
Okay.
Okay, like
And when will we start flux?
when we start the class.
Sorry?
Okay, you have any topic which you want to discuss?
Actually, the flux part, which was also coming in my exam.
Okay,
So I
flux
want
part.
flux, the Gauss law, I wanted to get over it very fast because it's coming in my test.
Okay, okay. So let's do flux part. Okay, we will do the ring and charge, the main application thing
No, no,
after.
no, no. I mean, like the whole chapter is coming, but the flux and the Gauss law both are also coming. So that's why.
Okay, don't worry, don't worry. What I'll do, I will teach the flux part before, and then after I will move to the your this field and ring part. Basically, we can swap both of them. Okay. The only idea is if you do, okay, let's do one thing. Instead of doing too many things, what I'll do, I'll just take the ring as an application first. Then I will teach the flux part. Then we'll move to the another application based thing. Understood?
Okay. Okay.
Is it fine? All right.
Yes.
So yeah, this is all for the session, and okay. Uh, Pratham, look, tomorrow I am not sure that I will be able to take your session or not. But look, if I'm able to take the session, that's fine. If I'm not able to take session, I will give you nearly 30 questions. Will you be able to solve that?
I may be, but tomorrow even I think I won't be able to attend because I have to go somewhere.
Okay, okay, that's fine. Then
So
okay,
I'll let you know if I'm able to complete. I'll,
okay. So what I'll do, I'll just till the today evening, I will provide you questions. You can solve them. Okay.
okay,
Okay. So yeah,
sure.
tomorrow I think I won't be able to take your class, and will notice you also.
Okay, okay.
Okay,
Thank you,
that's
sir.
fine. Yeah, that's all for the day. Goodbye. Keep studying. All
Bye.
the best.